Hello everyone. Today we are going to see about the subject Principles of Software Engineering. Myself S. Manigandan, Assistant Professor in the Department of Computer Science and Engineering from Kongunadu College of Engineering and Technology. So this subject consists of 5 units. In the first unit we will be seeing about software lifecycle models. In the second unit we'll be seeing about requirement engineering. Third unit is about software design, and the fourth unit about testing, and the fifth unit is about umbrella activities. So in the first unit we'll be seeing about process and its definition, benefits of a well-defined process, generic phases of software development lifecycle, verification and validation, software lifecycle models such as waterfalls model, prototype model, rad model, spiral model, and agile model. So let us see unit 1 in detail, one by one. So first of all, before going to the subject, we should know what is meant by software engineering. So the word software engineering is derived from two common terms, that is software and engineering, where software is the collection of programs, associated libraries and its documents. So all put together forms the term software. And the term engineering is nothing but a well-defined and scientific principles and methods for the development of some quantity or qualitable approach. So this is called as software engineering. So according to IEEE, so they define software engineering is an application of systematic, quantifiable and disciplined approach for what? For the development, design and operations and maintenance of software that is applicable of engineering to softwares. So this is nothing but all the disciplined and qualifiable approach which are meant in a systematic way for the development of software. Not only the development of software, it also involves the maintenance, design and development. So if you see the key characteristics of software here, it has different characteristics such as operational and traditional and maintenance are the different characteristics of a software. So next, categories of software and its application. So there are different categories of software. So let us see one by one. One is system software, application software, then engineering or scientific software, web application software, artificial intelligence software. So here system software is nothing but a collection of program, so which is written to service or serve other program. So for example, we can say compiler and editor or some of the system softwares. So next is application software. So these application softwares are standalone programs that solves a specific business need. So next is engineering and scientific software. So where the application ranges from an accuracy or an some other automotive stress analysis or some other application oriented or engineering oriented softwares comes under this categories. So that is called as engineering or scientific software. For example, let us we can say microbiology, you'll be having for example, if you're considering microbiology, you'll be having automated analysis of the internal structures of biological things. There we'll be having the software particularly meant for but the study of internal biological molecular structures. Like that we'll be having the scientific applications, different scientific applications will be having software. Next is embedded software also, which comes under this, so which resides within the product or a system. The software resides within the software or a system. So next comes the web application software. So here web application software is nothing but, so it consists of web applications or set of links, hyperlinks and hypertext files that presents the information using the text and limited graphics. So those applications are called as web application softwares. Next is artificial intelligence software. So the application includes areas such as robotics, expert systems, pattern recognition, artificial neural network, so theorem proving the game theory, etc. Not only limited to this, you'll be having vast applications for artificial intelligence softwares. So next topic is software engineering as a layered approach. So here we are having different layers. At the lower layer, you'll be having the quality focus layer, which focus on the quality of the software. So next comes the process. So the process here is the development or the set of activities which are used for developing the softwares. So next is methods. So here the method is nothing but, so you'll be having it will be provided with different technologies how to build a software. So those forms the methods. So next is tools. So to provide automated or semi-automated supports for the process and the method. So the below two layers are supported by the tools. So these tools will be involved in development of the software. A system for the support of software development, sometimes called as computer aided software engineering, is a kind of tool which is used for development of softwares. Next is key characteristics of a software engineering. So here we'll be having different characteristics. One is pay attention to the quality. So which is nothing but we have to give quality attention to the software which you are developing. Next is flexibility and expandability, where flexibility and expandability, which means that the software must be accessed by any kind of user, and whereas expandability is nothing but the software must be able to incorporate new functionalities as needed by the users. So next is cooperation within a team. So it is a kind of teamwork which involves in the development of software. So next is managing complexity. So it is a kind of key characteristics of a software engineering. Here modular design such as OOPS, that is object oriented programming, and design pattern techniques were used in the software engineering. So these are the basic characteristics of software engineering. Next is emerging trends in software engineering. So there are different emerging trends such as AI and machine learning in software engineering. So AI and machine learning products are powered by using software engineering. So DevOps practice, that is development team plus application team put together, forms a single team called as DevOps teams. So which is also the emerging trends in software engineering. Next is agile methodology. So which is a group of iterative and incremental development approach, so that emphasize flexibility, cooperation and collaboration in continuous improvement for the development of the software. Next emerging trends is cloud computing, so which increases the using cloud platform to develop the scalable and cost effective solutions for the software development. Next is cyber security, to bring a strong procedure for the security oriented systems and for development of software which is inbuilt with security procedures. So this forms the security, cyber security principles. So next is process, that is a well-defined software process is nothing but a collection of activities, actions and tasks that performs when some work product is created or a software is developed. So this all put together forms the process. So the process may include activities, actions and tasks which includes the software development. So first is activity. What is activity? So to achieve a broader objective such as communication with the stakeholder is a kind of activity. Next is action. So here action is nothing but set of tasks that produce a major work product. So action is nothing but here set of task. Next is task. So task is nothing but small and well defined objective that produce a tangible outcome. So this all put together forms the term process. So next is benefits of well defined process. What are the benefits of well defined process? So if you see, so these are all the benefits of well defined process. The first benefit is improved consistency and predictability. Next is better project management. So enhanced quality, increased transparency, continuous improvement and clear communications all put together forms the benefits of a well-defined process. So next is software development life cycle. So the definition for software development life cycle is it is an organized procedure for what? To create a high quality software. For what? To fulfill the user requirements. So in order to fulfill the user requirement, we have to create a high quality software. The procedure for the creation of this forms the software development life cycle. So next, the generic phases in software development life cycle. So what are the generic phases? So if you see, there are different generic phases in software development. The first one is requirement analysis. Next one is defining, design, implementation, testing, maintainability, and deployment. So deployment and maintainability put together forms the last stage of software development. So these are all the generic phases of software development. So let us see the phases one by one in detail. So first is requirement analysis. So what is requirement analysis? So what are all the issues and opportunities to achieve? So what are all the requirements needed by the customer? On the customer side, what are all the requirements or what are all the issues and opportunities faced by the customers? All put together forms the requirement analysis phase. Next is defining. So once the requirement is received, we have to define what to do. So that phase is called as defining phase. So next is design. So based on the requirement analysis and define what we have defined, we have to now go with what we want to do. That is what we are going to do. We should have a rough sketch of doing what we have to do it. Next is implementation. So implementation is let us create what we want. So in the implementation phase, we are going to make the blueprint, that is the blueprint developed in the design phase, into a new or a creative things or a software which is implemented in the implementation phase. In testing phase, we are going to test it what we have made it. So that is we are going to check whether we get what we want. In the deployment phase and the maintenance phase, so we will be going with what we want or what we have got or what it is closer, what we need it is closer, we have achieved or not, we are going to say it. So that is deployment and maintenance phase. So in deployment phase, we will be deploy the software and the user environment and we'll be checking on maintenance phase. Once the customer is working, he will be getting some errors on his side. So all put together, it will be rectified and it will be on the maintenance state. So these are all the generic phases of software development. So here is the software development life cycle. As we said earlier, so this is a requirement analysis phase. So here in requirement analysis phase, we will be gathering all the requirements which is need by the customer for the software development. So based on the requirement, you will be defining what we want to do. That is called as defining. Once we have get the defining, we will be having the designing. So that is the blueprint. Once we have designed it, we are going to implement and coding. Then we will be going for testing, then deploy it, and then maintenance. So this is the sequential flow of software development life cycle. So in this first is requirement analysis. So gathering the requirements which is need by the stakeholder or the demands of the stakeholder put together forms the requirement analysis. So here planning, defining this project scope, and we are setting the goals. This forms the requirement analysis phase. Next is defining. So here we are going to define, explicitly describe the record and the product needs and approve. We are going to get the approval from the client. So on the end, we will be getting the SRS, that is nothing but software requirement specification document, which will be the clear foundation for the software development. So the software development, that is software requirement specification, includes the following. So which are they? So what are they? First one is economical, legal, operational feasibility, technical, and schedule. So in economical, we have to see whether the project will be finished within the budget. So whereas in legal, we have to handle the project in a light of cyber laws and other regulatory frameworks and compliance. It should be legally bound. So next is operational feasibility. We have to check whether the client expectation is satisfied or not. Next is technical. So in the technical aspects, we have to check whether the system required by the software which is present on the customer side or not. So that is technically feasible. Next is schedule. So in schedule, it should be completed within the period set by the customer. So the time duration set by the customer, the product development must be finished. So these are all put together forms the software requirement specification. So next is design. So here we are going to convert the requirements into a blueprint. That is, we are going to change the requirements into an outlet or an architecture where we are going to do the designing. So at the end of the designing, you will be getting the design document specification blueprint. So there are two different types of designing. In terms of designing, you'll be having one is low level design, another one is high level design. So in this, we are having different types of diagrams for converting our requirements to the design. So first is UML. You'll be having different UML diagrams such as use case diagrams, sequential diagrams, and many other diagrams will be used for converting our requirements to the design. Next is implementation. So in this phase, we are going to the developer is going to convert the design into a source code. So that is design document plus software design all put together, we are going to convert into a source code. So here this implementation is the longest phases of the software development life cycle. So it takes too long time for the development, because it here only we are going to have the coding and the implementation put together, we are going to do it. So it takes a long time for the development phases. So next is testing. So once the program is completed, modules are ready for testing. So we'll be having to subject it to rigorous testing. We'll be having different types of testing such as unit testing, integration testing, user acceptance testing. All the tests are repeated until the program is bug free, stable, and they meet their user requirements and the system business requirements, etc. So the testers, once the document is, that is once the system is ready, they will be referring to the software requirement specification document, and they will be ensuring that whether the software meets the requirements of the customer or not. So this put together forms the phase called as testing. Next is deployment. So once the software is test free and once the testing phase is over, we are going to deploy the software on the customer end. So it will be installed, configured and operational, and frequently it will be user training and post deployment verification will be done on the user side. So once the software is deployed on the user side, so this phase is called as deployment phase. Next is maintenance. So once the software is deployed, issues may arise when the customer or the user runs the program or runs the software. He may face some other errors on the his own side. So these errors will be pointed out and those errors will be solved. So this put together forms the maintenance phase. Normally this includes three activities. One is bug fixing, that is the user's errors will be fixed, then we'll be upgrading to the new version, then we are having the enhanced version. So all put together, all will be based on the feedback received from the customer. So this is called as maintenance phase. So finally this SDLC is having that is we are going to categorize into 6 stages. One is planning and analysis, second stage is defining the requirements, third stage is design, fourth stage is development and implementation, fifth stage is testing, at last deployment and maintenance. So this forms the generic phases of software development lifecycle. So next is verification and validation in the software process. So verification helps in examining. So normally verification is nothing but verification and validation. It is mainly for checking whether the software system satisfy the specifications, standards and fulfill the requirements needed by the customer. So both the phases which is used for investigation of the customer need is satisfied or not, we are going to face. So this verification helps in examining whether the product is built rightly according to the requirement. So we are going to check whether the product is built rightly, that is called as verification. So validation is nothing but we are going to check whether the product is built to meet the user need. So whether the product meets the user need or not is called as validation. Whether the product is built rightly is called as verification. So these are the verification and validation strategies in software process. Next is SDLC models. So normally SDLC models, there are different types of models. Generally it is categorized into three types. One is incremental process model, evolutionary process model and the ancient model, that is waterfalls model. So all the models which are going to see will be categorized under this types only. So first one is waterfalls model. So the waterfalls model is a sequential model or linear sequential life cycle model for software development. So the name waterfall is given because it's look like a cascaded waterfalls flowing in a cascaded way. So it was introduced by Winston Royce in 1970. So this is the first software development life cycle model. So here, before going to next phase, the first phase must be completed. Then only it is possible for going to the next phase. So likewise, each and every phase, after the completion of each and every phases only, you'll be going to the next phases. So here, first one is requirement analysis. So as we see in the software development life cycle model, so here requirement analysis is the phase where we are going to get the requirements from the customer side. So we are going to get the requirements from the stakeholders. This is the requirement analysis phase. Once this phase is over, we'll be going to the system design phase. So here the software will be designed or the system will be designed, so based on the requirements received from the customer. So after this phase is over, then only we are going to the next phase. So that is system design phase. So once the system is designed, we'll be going for implementation. In implementation phase only, we are going to have the coding session. So this is the longest phase. So once the implementation is over, we'll be going for the testing phase. So here in testing, we will be testing whether the requirement is met by the customer. So the requirement specified by the customer is meted out or not, we are going to check in testing phase. At last, we will be deploying the software on the user end and you will be having maintenance. So here it is called as waterfall because each and every model is in cascade, it is connected in the cascaded way. So likewise it is flowing like a water, so it is named as waterfall model. So here once the first phase is completed, then only it will be going for, we will be going for the next phase. So it is an incremental or it is a sequential flow model. So this is all about waterfalls model. Next is prototype model. So prototype is not a complete product. So it is a functional replica or a toy implementation of a model or a simple representation of a model. So it is applied when the customer do not have the exact project requirement. So when he doesn't know the project requirement exactly, then we'll be going for the prototyping model. So this is iterative trial and error method which takes place between the developer and the client. So it is an trial and error method. So it will be taken place between the software developer and the client. So here are some of the examples for the prototyping model. So here this is the prototype model for building the house. Actually the actual house will be like this. So before going for building a house, you will be giving a prototype. So like this, so the user will be having the clear idea about the toy documentation. So this is the toy model of the actual house. Like this, you will be having a prototype. So similarly, this is the prototype for an actual car. So the actual car will be like this. So this is the prototype for this chair. So this is a prototype for uh, that is the layout or a frame for an login page. So this is a prototype. Normally the actual output will be like this. So this is an example for prototype. So this is the prototype model diagram. So first you will be having the requirement analysis phase. Once the requirement is gathered, so you'll be having two phases in requirement in prototype development. So this is first phase is called as prototype development, next one is iterative development. So here in prototype development you will be getting the requirement and you will be designing the product and you will be building the prototype. Once the prototype is built, the customer will be called for evaluation of the prototype. Once the prototype is satisfied, then we'll be going for the development of the actual product. If the prototype is not satisfied, what we'll be doing, we'll be refining the requirement and we'll be going for again the quick design and again we'll be rebuild the prototype based on the customer session. So here we'll be having the feedback from the customer and we'll be redesigning the product. So likewise the prototype will be built at first. So next we'll be having the actual development phases, that is design, coding, implementation and maintenance phase, testing and maintenance phase. So this is an iterative development. So first the prototype will be developed. So based on the prototype development, so it will be you'll be having the next phases such as software development phases, design, coding, testing and maintenance. So normally for prototype development you will be having two stages. One is prototype development stage, another one is iterative development stage. So this is about prototype development. So we will be going for this model only if you are knowing, if you are not having the clear idea about the product which we want to develop. So this is about prototype development. So here the phases of prototype development, we are having two phases. One is prototype development phase, another one is iterative development phase as we seen in the previous slide. So next comes to the RAD model. So RAD model is nothing but rapid application development. It was introduced by James Martin in the year 1980s. So it is developed to address the limitations of traditional software models. So here, so this is the rapid development model which was introduced by James Martin approach, using James Martin approach. First the requirement will be gathered. So here you will be having user design phase. So once the requirement is gathered, you will be designing the prototype and testing the prototype and redefine the prototype based on the user requirements. So once the prototype is designed, you will be going for construction and cutover phases. So here in rapid development, that is RAD model, we will divide the analysis, design, build and test phases into sequence of iterative development cycles such as building, data modeling, process modeling, application generation and testing and turnover. Normally you will be going for this RAD model if the software development phase is only within 60 to 90 days duration, that is 2 to 3 months. If I want to deliver a software, then we will be going for this RAD model. So following all this business, this modeling phases, there will be different teams. Each and every teams will be following this modeling. At last we will be developing a software. So this is all about RAD model. So next is spiral model. So here the spiral model is developed by Beham in 1986. It is a risk development software development life cycle. So it is a combination of waterfalls, iterative and prototype model. So this software development model is a series of incremental model which was released per each spiral. So it is also called as meta model. So normally in spiral model you'll be having four spiral. The first half will be four four partitions of the spiral. The first half is called as planning. Next is risk analysis. The next one is engineering and execution. And the last part is the evaluation phase. In the planning phase, you'll be having the requirement analysis gathering and planning will be done in the planning phase. So in the next, you'll be having risk analysis. So based on the requirements arrived, you'll be having the risk assessment or risk analysis will be done in this phase, where you'll be seeing the risk which is about to occur due to the implementation of the software. Then we'll be doing the engineering and execution process. That is, the software will be developed in this phase only, in this part only. Next we'll be having the evaluation phase. Once all the three phases is over, you'll be going for all the three part of the spiral is over, you'll be going for evaluation, that is customer evaluation. Once the customer evaluation is satisfied, you'll going for the delivery, that is deployment of the product. So this is all about the spiral model. So here this is the progress. So this one is called as planning, this is risk assessment, this is execution and engineering phase, and this is we are going for next, that is evaluation phase. So here in this two half you'll be having the risk management prototypes and you'll be having the development phases in this two half only. So here we'll be identifying in the first half you'll be identifying the objective, here we will be having the risk management, and here we will be having the actual development, and here we will be having the evaluation. So this is all about the spiral model. Next is agility. So agility is nothing but this is the last topic of our first unit, that is agile methodology. So agile is nothing but the ability to respond to the changes from the customer requirements, technologies and people. So it is nothing but in each and every phases we are able to respond to the changes or requirement which is needed by the customer. So this is called as agility. Agility is normally called as the ability to respond to the changes. It is also called as I&I process. It is incremental and iterative process. So this is all about the agile methodology. So first you'll be having planning, next you'll be having designing phase, development phase, testing, deployment, then review and launch. In each phase you'll be having the customer interaction. The customer will be interact, you'll be giving suggestion. So the suggestion will be incorporated or new additional requirement will be incorporated in each and every phases. So that is the ability to adapt to the changes. So this forms the agility. So time span for the models. In waterfalls model, the waterfalls model may take uh, in waterfalls model you will be completing one phase and then only you are going for the next phases. So it may take 2 to 3 months to complete the requirement analysis and gathering phases. Then another month for it will be taking designing. Likewise coding it will be taking 6 months. Testing likewise it will be going. Whereas in agile methodology in iteration 1 itself you will be having requirement analysis, design, code, testing and user acceptance and learning. So all put together you'll be getting the requirement feedback and you'll be going for iteration 2. Based on the feedbacks received from the customer or the changes received from the customer, you'll be going to the second development iteration phase. Likewise, based on the it is having the ability to adapt to the changes given by the user at any time. So this is about agile methodology. For example, in iteration 1 we will be framing only the outlet, that is frame alone. In the second iteration you'll be adding some components like zooming, etc. In the third iteration you'll be having the more tools will be added. Like this, in iteration 1, iteration 2, iteration 3 you'll be having different stages of development based on the customer needs and requirement changes. The design also gets changes. So next is basic principles, that is agile principle manifesto. First one is the customer satisfaction. You all know the customer satisfaction is the ultimate aim of the software engineering methodology. So here customer satisfaction plays the first principle of agile methodology. Next is changing the requirement. So each and every phases you can have the changing in the requirement. So once the changing is obtained, the software must be able to adapt. The software construction must be able to adapt it to the changes which is required for the software development. Next is development of software, delivery of software. So delivery of the software must be within the schedule which is meant by the customer. Then cooperation of the developers. There must be cooperation among the team which is developing the software. Next is building a project. So building project is also an important phase in terms of important principle in terms of agile methodology. Next, face-to-face conversation between the uh, team members must be there for software development. So seventh principle is progress of software. The progress must be simultaneous progress or progressive growth must be there for software development. Then development pace, likewise technical excellency, simplicity, self-organizing team, and last reflection and adoption team will be there. So these are all the 12 agile principles for development of the software based on agile methodologies. Next is agile methodology. So agile methodology is nothing but set of approaches for what? For development of softwares based on agile methodologies. So there are different popular agile methodologies such as Scrum, Kanban, extreme programming, lean software development, crystals, feature development, driven development, dynamic system development models, adaptive software development models, etc. So here first is Scrum. So Scrum is nothing but it is one of the popular agile methodologies where the design to deliver the work is an iterative cycle called as a sprint. Normally it will be of 2 to 3 weeks. So it is a popular software development scheme that is Scrum. Next is Crystal. So Crystal is nothing but you will be having the software development methodologies such as it is a family of lightweight methodologies which is designed to have a unique characteristics of the project such as team size. You will be having the different team size in crystals. Next is system criticalities. Then you will be having business priorities. For example, in crystals, if the project size, that is project size is of 6 members, then it is called as clear. The crystal is called as clear crystal. So if the people has if the project has 20 members, then it is called as yellow crystal. Likewise, based on the people size, the crystal's size also varies. Next is Kanban. Here in Kanban, you'll be having the visual flow of workflow. The workflow will be represented in 4 categories, that is backlog, doing, and review, at last done. So it will be in a pictorial way of representation of workflow. So it is called as Kanban in order to follow the software development methodologies, that is flow of software development. Next is extreme programming. Extreme programming is also a software or agile development methodology which focus on high quality software improvement development and testing and team maintainability of software development. So it is based on test driven and pair programming and also on continuous integration. You'll be having extreme programming. Next is dynamic system development. So in dynamic system development, you will be having the software development based on the dynamic way, where you will be having different methodologies put together and you will be having development phases. It is developing. Once the requirement is keeping on changes, you will be going for dynamic system development. Next is feature driven development. So feature driven development, here you will be focusing on based on the overall products, that is feature centric model. So it is based on feature centric model. So it means that you are developing the feature bit by bit. So we are going to develop a feature for the product bit by bit. Next, it is based on getting the feedback from the customer. You will be developing the features based on the feedback given by the customer, then putting them into a product over time to improve them. So all put together forms a product. So this is all about the different agile methodologies. So this is the first unit about the software lifecycle models. Thank you.